Welcome to Insight Builder channel and another interesting video on revolutionize your search experience with hybrid search, combining image and text search using TxtAi and its embedding indexes. This particular video is going to work on top of various other tutorials that I've already discussed upon TxtAi. First, the steps that we are going to take in this discussion. We are going to work with both image and text or caption based searching in this particular discussion. When you are going to work with any of the unstructured data, whether it is image or text or audio or whatever it is going to be represented as vectors inside the machine learning execution environment. Whether it is going to be your LangChain, Hugging Face Hub, or whether it is going to be OpenAI embeddings, whatever the area you are going to work upon, these data, that is the unstructured data, has to be in the form of vectors. Whenever these data is converted to vectors, we can do a similarity search on these vectors by various algorithms. In case of TxtAi, the idea of doing a vector search has been, supercharged, literally. So there are multiple ways to do searching in TxtAi, and also one of the main concept that I learned in TxtAi is that you can run SQL-like search options or search commands inside on the embedding databases. So we will be seeing or using that facility that is provided by TxtAi, very extensively in this video. First, the steps that we are going to take. So we are going to take an image data set. It can be with or without caption. So without caption, we can actually use one of the options that is available, that is pipelines that is available in TxtAi, and get the caption. So that also I will be touching upon, but I will not showing you the example in this video. Second, you have to create the embedding using the clip model. So I will be explaining what is clip model in a couple of minutes. Next, we have to store the index in the embedding inside the index, that is the database, and then we are going to querying the index. So when you are going to query the index, we are going to use two methods. We are going to send an image and query the index, and also we are going to send text and we are going to query the index. And finally, we are going to list the matches that is coming out. This is what we are going to do. It's pretty simple, right? As I told you, we are going to use hybrid search. So both image as well as text. And you must be right now thinking, so Kamal, if I am not going to have image, can I use audio? Can I use can I use any other kind of input, like if I want to use video, can I do those things? Actually, you can. Only thing is that how you process the data and how you convert it into vector is the main challenge that you will be facing. You will be seeing those steps as we go into the tutorial, as we go into this discussion. First, I also want to thank Ashrak as well as Param Agarwal, both of who have got the fashion product data set. Param Agarwal had uploaded into the Kaggle, and Ashrak had taken the data set and uploaded it into Hugging Face datasets. So we'll be using Hugging Face datasets. And I'll be also discussing how to work with datasets a bit. I will not be diving deep into that. The notebook that we are going to work for this particular discussion will be shared with you guys in the YouTube description below this video. So take a look at that, start working on with the repo. The idea of sharing these videos, as I always say, is to help you practice and to solve the problem that you have. So let us go to the top. So what is the problem we have got? The challenge that we have got is we need to search using multiple modalities. So we want to search with text, we want to search with image, we want to create a user experience which is very fluid, like how you see in Google, right? So you can actually use Google. If you go to Google search bar, you can click on the image search option and you can upload the images. The same way, in your products, in your tools that you are going to generate or develop, you can use these techniques too. The way Google search image works and the way the image search that we are going to implement will be a little bit different. See, I have not actually gone through the algorithm that Google is using, to be honest with you. But if you have some ideas or comments on that, do let us know in the comment section. That will be wonderful for the entire community to learn. With that said, I would like to go back to the final page. So understand one thing, that the idea of sharing these videos is to help you, not only you, to help the entire ecosystem to develop together So do share it with others, these videos, and also subscribe to my channel. So further updates related to artificial intelligence models, libraries that help the artificial intelligence model implementation in Python will be shared with you guys directly to your YouTube dashboard. With that said, let us go to the browser. So we are overdue right now. If you're new, completely new to these concepts of large language models, AI models, how these things work, then I would suggest that take a look at this particular playlist, Mastering NLP with Hugging Face. I have discussed a lot on the types of tasks, types of models, available inside the Hugging Face hub, which is for which you can use it for free. The models are hosted there for free. You can take a look at this 11 NLP tasks and 18 vision tasks that I discuss in detail about in these videos. Also, TxtAi is I have been introducing TxtAi for last couple of videos, so these are the videos that I have been introducing. I'll be attaching these videos as tags to the current discussion that we are having. So take a look at these videos also to come up to speed with TxtAi. It is not just TxtAi. There are various other libraries that support the NLP practicing. So we have 2V, we have unstructured, we have LangChain. So there are a slew of libraries. Only thing is that you need to know what is the problem that you are solving. That is where it all starts. In this case, we already know the challenge that we are having. So we have a set of images. We may or may not have the captions, and we want to search these images and get the reply from the vector stores. So that's our challenge. How are you going to attack it? Is by using a couple of models that is available inside Hugging Face, and we are going to use pipeline constructs that is provided by TxtAi. So we are going to use Torch Vision, IPyPlot, TxtAi, and datasets library. So all this will get installed once you open this notebook. This particular notebook will be available to you guys from this particular GitHub repo. So don't worry about that. It will be shared with you guys. And okay, so let us dive into that. So now I have told the libraries, and we are going to also work with various images. So images means you need to plot the images. So for that, there is a library called IPyPlot. That is what I am importing here. And in order to work with images, to get their format, get their size, etc., we have to use pill module. So that also will be used in this particular notebook. In case of TxtAi, we are going to work with embeddings and caption. So this is what I was talking about. So there is a pipeline called caption inside TxtAi, which can be used to caption the image that you are providing. So for an example, I give an image. This is okay. Let us take this image of a dog. If I give this image to the caption, the output will be the text related to the text describing the image. So I have discussed about these tasks or pipelines in the earlier videos on TxtAi. Take a look at that for a brief on caption also. But we will not be using caption in this particular discussion, because the image dataset that we are going to work with already has got the caption with it. So you don't need to create a caption. That is one of the benefits. Now, what is CLIP? CLIP is contrastive language image pre-training. So what is happening is this particular model brings in both text as well as image together, and it is pre-trained on the pairs of text and images. So when it is done like this, so whether you use images or whether you use text, you can get the vector similarities, and then the similar objects are returned to you. Also, it can work with zero-shot capabilities like GPT-2 and GPT-3. However, we are going to concentrate primarily on working with vector stores and similarity search. We are not going to work on zero-shot capabilities in this particular discussion. This is okay. So you may not be aware of zero-shot capabilities. You may not be aware of what is vector search. So please please work upon the earlier videos that I've already shared. You can come up to speed rapidly. The major point is that to give a brief, so vector search is done based on the vectors, the distance between the two vectors. So vector by its nature will contain multiple elements. So this is a vector, right? So you will have t1, t2, t3, t4 up to tn, depending on the embedding that is done, so depending on the encoder. So when we are going to do the vector search, we will have, so this image, when we are going to convert it into vectors, that will also have a series of numbers. So then we will do the distances analysis between multiple vectors and try to find the similar results. Okay, when it comes to both image and text, so there you might be wondering, okay, how will that work, Kamal? What will be the will there be any kind of new technology that is being used? The overall concept is still the same. The vector search is still done based on the distances between the vectors, but only thing is the way the individual vectors are created is little different here. So you can see here in contrastive pre-training, both the text as well as the image is converted into kind of a matrix, and then it is trained on the final data. So this is little more involved than the regular single dimension vectors. This is going to become multiple dimensions. The detail of the clip, the model, is shared with you guys in the link. So there are couple of options available with clip. So clip was first of all generated by OpenAI, and then the open source implementation of the clip model was done by MLFoundation. You can also see the implementation of clip from the Hugging Face library also. There is an implementation by their team too, Hugging Face team also. So you can read up about these models in a more detailed fashion in this particular. I have shared the link in the bottom. So you can do read it up. You will get a more clarity on how this model actually works, because there are lots of activity or lots of steps that goes into creating the clip model. So it's not an easy task. Also, there are ways to work with multiple models. So if you see here, in order to tokenize, in order to work with image, in order to work with various text models, so the details are provided inside the Hugging Face hub. So you can take a look at that. I'm not going to go into details of this particular model right now, but I would really urge that you can take a look at these things. Let us go back to the discussion at hand. Initially, we are going to work with the dataset that is shared by Ashrak, fashion product images -small. This dataset has been already uploaded in, as I explained, from Kaggle. It has been converted to Hugging Face datasets. Once you load, so I'm taking the train part of this dataset. So there is test part also, which is separate, which is not much of a difference. It doesn't make much of a difference to us. So there is total 44,000 products or images. However, in the train sample, we have only 40. Yeah, we have that much amount additional models also. So working with the data sets from Hugging Face is much more intuitive. Why? Because what happens is, in case of the Kaggle dataset, you will be given CSV files, and the image files are maintained in a separate folder. So you need to do some mapping. In case of dataset, what happens, that is Hugging Face datasets, is that both the ID and the image detail, the image object itself, everything is kept into a single dataset. So you don't need to worry about the mapping of the ID, gender, etc., the data of the image and the image itself. So it is already mapped for you. That is one of the biggest advantage of working with Hugging Face datasets. So here, what I am going to do is, so image data is what I am loading. By using load dataset, I am loading the image data, and once I load it, I am only taking the captions, that is the product display name, and the images, that is the image part of this particular dataset. Rest of the data I am not actually taking it. So I will tell you why. Why is that? Because rest of the data still comes with me. You see the given caption. Once I take this out, it is the caption of the particular product. And here I am plotting. So using ipyplot.plot images, I am plotting the first two images inside this image list and the first two captions. So that is being done, and you can see the images here. So this is the raw image that we have got. But if you go to the image data, that is image data itself, if you go to this image data and if you try to take a look into that, you will see it has got a lot of information like ID, gender, master category, etc. Right? We can still use them, but how we are going to use it is more important. Correct? What we can do is, we can actually work with the image data. Okay, I am just showing it to you here that I can actually split I can take the necessary parts of this image data, okay, and I can create lists. This is required. In the future, I will tell you why I'm doing this. But when I am going to do the embedding, so what I'm doing is I'm taking the path. This is the path, the ID that I'm going to give for the embedding. That is image ID. That is here, the image ID, and the object. So this object is going to be the image, this particular image. This is a image object, that is the picture object. You can see the RGB, you can see the size, etc., right? And we can get the image width, format, etc., and also we can get the caption here. The caption is the product display name. I'm taking all this as data. So this is data. That is something that I'm going to embed, and this is going to be my ID. So all these things I am going to convert into a tuple, and I am going to store it into fashion underscore data. So this is what this particular loop is doing. Okay, so fashion data now contains the data structure in the format that you can directly use in embedding. So when it comes to embeddings, that is the embeddings that you are going to do using TxtAi construct, we are going to pull in sentence transformer clip VIT B32. So this is the model that you are going to use. And once you are going to use, two things are very important here. You need to add content equal to true. Without that, it will not actually take all the contents that is provided to it. It will not take it. So content should be equal to true, and objects equal to image. So this is something that we are informing. This is a configuration that we are providing to the embeddings. Okay, so this is how the embedding is getting initiated. After that, it's pretty simple. So here what I'm doing here is that I am going to save this embedding. So before I save it, I just want to ensure that in my folder there is no any fashion underscore data underscore index folder. So I want to remove that. Anyway, this is something that I have already coded it here. And I'm going to only send 1000 pictures, first 1000 images into the index, because it takes a lot of time with the available RAM and available processing power. It takes considerable amount of time. So sending 44,000 images into the index is going to take more than 1 to 1.5 hours of time for indexing. So I would suggest that only work with minimum number of examples and understand what is going on. That is more important than taking it to production. But yeah, when you're going to take it into production, the processor that you're going to use is going to be also different. Also, once you load this data set, or once you load the images into the embeddings, after that you can work with a simple simple processor for retrieving the data. You don't need huge processing power, but for sending or doing the vector embedding and loading it into the database or index takes sufficient processing power. So that is something that you need to be aware of. So this is the saving process and this is the loading process. So if you already have got the index with you and you can load it, this is pretty important if you're going to work on this particular notebook multiple times. So you don't want to do the indexing again and again, because it's going to take a lot of time. So I would suggest that save this index, then make a zip of this index and store it separately, and then you can load it whenever you want it. So this is something that you guys can try it out. In other notebooks I have already done that. In a couple of other notebooks where I discussed, you can use the zip command and you can do the zip of this particular index. Now comes the interesting part. So once you are done index, right, you can do a search. So fashion underscore index dot search, and if I say select star from TxtAi limit 5, you see all this information. So you get the index ID, the ID that you're pushing in, the text that is available, and the most important point is this data. So this is the one that gets actually embedded properly and along with the object. So both of these things get embedded. And when you're working with regular embeddings, regular text embedding, we actually give these three. So we give the ID, we give the text, and we actually make the tags equal to none. But in this case, when you're working with images, you have to have this kind of a format. And you see this when I use select star from TxtAi limit equal to 5, I am getting the first 5 details that has been pushed into the embedding. So this is what I was talking about. If you don't enable this content equal to true, then you cannot do this kind of searching. So keep this in mind. This is already there in the documentation of TxtAi, but still I want to reiterate it. Well, we can move forward right now. So we already have the embeddings, we already have the necessary images. All you need to do is start doing the similarity search. So this is the first similarity search that I'm doing on image 0. So this is the first image inside the image data list. So you see why I made it as a list here. And So if you go up here, so you see this image data equal to 0. So the image data index of 0 is about the men's apparel, which is a blue shirt, navy blue shirt that is provided, and we are going to work with the object or image of that particular data. This is what I am going to do the similarity search upon. So you see, that is what I have done. So that is the reason why I also showed the data structure for you guys to easily understand. And what I'm doing here is, I am not giving the entire select star. So I am taking number of only specific columns here. So I am taking ID, I am taking the object, and I am taking the score. You see that here, object, ID, score, caption from TxtAi, and you see the result here. So you see the objects that are linked with this particular image, which is closer to this image. So I will explain to you how the image looks, what image gets returned back. So you see the image name is, the images that are getting returned back is 2 gray socks, Park Avenue blue pattern tie, and Park Avenue men brown tie. So you see the pattern already. So the images that are getting returned has some similarity already with the color of the image that we are sending in, right? The color we are sending blue, we are working with men, and we are working with some kind of shirt, etc. And once you get this output, so once you get all this output, you can print, you can plot this image. To plot that image, I am going to use this loop, and you see the images that is getting plotted. And now you can see what is similarity searching with image. So see, if you are going to send the image as a similarity, so this is going to look at the image as a whole. It's not going to know that it is a shirt, it is a tie, or whatever it is. It is going to see the color patterns, it is going to see the numbers that this particular image creates, and with respect to those numbers, which other images come closer, that is what it will be returned. So this is something that you guys have to clearly understand. So sometimes you might be expecting, okay, if I send a shirt image, I will get a shirt image back. Not really. So this is something you can actually tune it. So at this moment, I have not done anything. I have simply taken the data set that is available in the open. I have done the embedding, then I have done some basic data structure modification, and I am showing it to you, right? I have not done any kind of data processing here. If you do data processing, if you work on these images, work on these, how it is getting embedded, how the caption is getting written, how the images are stored, if you can work on those things, and if you can understand this much better and practice, that is more important, then you can have better results also. But what I wanted to say here again is that the image that you are going to do the similarity search here will be converted to numbers and the vectors, that is, and then the vectors similar to the vectors will be used for do the similarity searching. Okay, so now you saw how the image search works, right? You can try with some other images also. So let us say, let us take some other image. Let us take image number 10, and I am going to do a similar kind of a search again, and let us see what kind of images come out. So first of all, let us see what is the image number 10 is about. So let us go up, and here we can change it to 9 to 11. So I don't want to print all the images, because that will be very difficult to manage in a small screen. So you see that it's Skagen men black watch and Puma men shoes. So let us now, so whatever we are going to embed will be Puma men future cat, the Puma men black shoes. Okay, so that will be number 10, right? And I am going to do the searching here, and let us see the image results. Let us check the result, and we see that we again get, just a minute, let me recheck it. I suppose that, okay, when I was doing the search for image, we cannot actually use the SQL like querying. So you have to use the image object directly. So I reviewed the code and I understood that if I use SQL-like querying, the replies that is coming out of the search is wrong. So you have to only use the image object inside the search to get the image details. But once you do that, you will actually get the similar image results. So you will get how many, by default, you will get whichever images are coming close to it. More than 9, you will be getting it. More than 0.9 score will be returned to you. And here you see that these 3 are returned. By default, whichever image is actually having score of 1, that is image 1. And that is image 0, image data 0 is having score of 1 because that is the same image. But there are other images that is also coming close. But in order to get the details of these IDs and their details, for that you can use the index search using select. So select star from TxtAi where ID equal to 15970 or ID equal to 8741. So what will this return is, this will return 2 data. So this will return both index ID along with the data and also the index ID of 8741. So this is very interesting and useful for us. You don't need to use other constructs that is available in Python, right? You can still use find method and do other ways of getting the same information. But why to do that? You have the direct command options available inside the search itself. After you get this result, then you can use the object of this particular element, and then you can get the images. So you see here, this is the image that we sent in, and this is a similar image that we got. So this is what the first step is, where you use the image to do the searching on the dataset that is the embedding that you have created. I hope that, let us go back to the presentation for a moment. I hope that you understood the process right now. So we take the image dataset, we work on the embedding using clip model, we store the embedding using index, and then we start querying using either image or text. So we are already done with image. Next we'll be doing with text. And here, whatever we discussed, that both image and text will be represented as vectors, and then it will be stored inside the embedding. I hope that you guys are understanding the entire steps that is going into getting the necessary result. Let us go to the browser again. Here we are going to continue further. Now what we are going to do is we are going to use search using the text itself. For using text, you don't need to worry about how to send the search. So either you can use women tops or whatever search you are trying to do. You can use women tops directly as search, but I would suggest that go with select option. So with case of this particular text searching with TxtAi, it is very good. So I have already tested it, and you can use select object caption from TxtAi, and it will return to you the both object and caption, which you can again do the processing and then get the output. So you see that we are asking for women tops here, and we are asking for 5 results, but we are getting only 3 results. That is because the dataset that we are sending into this index is only 1000 in number. So if you have a higher performance or higher power processor, you can send in all the data, that is 44,000 data all together, and you can do the processing also. Or you can do it other way. You might have a higher processing power machine in a separate system. So you can use that machine, do the indexing, take the index, convert it into zip file, and then you can load it here also. So that is also one of the things that you can try it out. These things are extraneous to whatever we are trying to do right now. It is extraneous to whatever objective we have. But all these things you must be aware. All these challenges will come into picture when you are going to work in real time. So ensure that you know how to get those additional steps accomplished. Also, you might have to tell that these steps might be required when you are working on a new product, because once you start working on the product and suddenly at the moment where you are going to load all the index, then you find, okay, my processing power is not sufficient. That will not look good, right? Your project will actually get delayed. So it is always better to understand the bottlenecks that a particular activity or a particular solution might create, as I am explaining here. So there are bottlenecks available from the loading of the dataset. You can do something else also. So if you are having lesser processing power, right, you can load the data in batches. So there are options to do that in TxtAi itself. that I have not really touched, do look at the documentation for understanding those things. So there is a way of batch loading the data also, which is little bit better when compared to loading it like this as a complete data set. Okay, now coming to the text. So once you do the text searching here, you get the direct output, and then you see that we have got the necessary data output here. This show HTML is part of ipyplot. This is not part of the model. So don't get confused with this. Only the result you need to look at it. Okay, with that, we have actually come to the close of this particular video. I hope that you understood the entire process of doing the vector embedding of both images as well as pictures, and then doing the search based on images as well as pictures. Images and text. I'm sorry about that. I missed the vocabulary there. I'm talking about both. You must have understood the both embeddings of image as well as text, and creating the indexes, and then you must right now understand how to use image and text for searching the index and getting the list of matches. We also saw the challenges if you are going to use SQL query method. If you are going to use image inside the SQL query, it was not working, as I already demonstrated. I had made the mistake when I was doing the entire discussion notebook. Then I realized when I was discussing with you guys, when I was making this particular video, I realized the error and I corrected it. So like this, new challenges will occur to you also, and ensure that you understand what is going on beneath the system. So that will help you to debug the issue really fast. So that is more important also, that I wanted to share with you guys, because whatever I'm trying to share with you guys, it's coming from basic trial and error that I am also executing. So it's not that I know everything by myself. I am also reading the documentation. I am also trying to learn along with you guys and presenting it. So I hope that you understand what is going on as a whole overview, from the modeling aspect, from the getting the images embedded, creating the indexes, working with the index and searching it. With that said, I would urge again that you guys actually share this information with everybody, and do leave a like if you like this content, and most importantly, do subscribe to my channel for further updates related to similar videos on artificial intelligence related libraries, Python ecosystem, and also large language model related libraries. With that said, I would like to end this video with 4 words as usual, that is practice, 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 practice. Have a great time, guys. See you.